Hi, Arun.
Just a minute. I'll just.
You can hear me, right? Your voice is a bit low.
Yeah, I can hear you.
Ah, fine. Now it's fine. Yeah. Okay. Fine. Okay. Check this as well. Yeah. 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 Today we will see about one of the tools, right, which IBM has created for the for analyzing your complete mainframe application. Okay, so
Mhm.
as we speak, right, so there are different I mean, for modernization they need to look up for a solution which will help to modernize the legacy application. It can be on any kind, right? For example, you want to completely come out of mainframe and develop a application for you, right? And in a modern languages like Java, Python, Angular, and whatever maybe. Okay, but
Mhm.
there are things which we need to understand, right? How we are going to do it, because this mainframe legacy application doesn't have a documentation or any kind of overview. That's the main problem here, because if you take any banking solution, right? So if you take any bank, Citibank, Standard Chartered, HDFC, ICICI, or JP Morgan, Barclays, Bank of America, right? Even if you take it in the Europe side, if you or Commonwealth Bank of Australia, or Danske Bank, Norway, and then KBC. So these are all different kinds of banks in different regions, right? So every region, you see every bank, they have their own IT processing. I mean that they maintain their source and the code, right? You can see
Mhm.
any bank, any big banks, right? So they have that, because they develop their systems, the processing systems. Okay, the core processing systems.
mm,
It not only on the credit cards came way later than the initial banking. So when you speak about banking in the initial stages, it was just like to have an account where you can deposit money, or you can withdraw money. Okay, so that was the
mm,
primary thing. So initially the cash was the only purpose, then it came the ATMs, and then you can do loans, then trading, and all those clubbed together, right? And
mm,
each and every bank in each and every region, they develop their, see, even in US, if you take a system of JP Morgan and Barclays, right? So these are two
mm,
different banks, but they run the business on US banking, right? But still
mm,
you cannot make a one system, okay, any one solution which could run both these banks. Or if you want to create any product, right? I'm just creating a product for banking in US, okay, or
mm,
a global banking solution, okay, but will that be able to fit for these two banks? No. So that's the
mm,
problem. That's the problem. This mainframe, they cannot just plug out and plug in with any other new products. Okay, see, Amazon is there. Like Amazon, you have Flipkart, right? Both are different
mm,
entities, but
mm,
if you can create a product which could run on, which will be able to run the same retail marketing on one app, right? So that is not a problem, because
mm,
the solutioning is same, almost same, so it doesn't have much of any big difference. Okay, but this is different. So that is the reason, if you want to do this, you definitely need to understand the current process which is already executing on the mainframe. Yeah. But
mm,
for that, you don't have any what to say, the proper understanding or the overview of the complete application which has been developed for JP Morgan, which is developed for the Barclays, which is developed for the Standard. So you don't have such a one. Okay, then you need to dig further. So even the main problem here is the dependency with the older people who have been working on that system for past 30 years. Okay, they know the
mm,
complete system. Okay, but the aging air force, and then they want to go on retirement. So now what's the problem is they don't know how to continue this. Okay, that, but even if you ask any person in India, right, by maybe maybe in 1990s, right, maximum, or 1995, later only we moved into the computer developments and other things, maybe mostly from Y2K problem from 2000, right? So from there, IT
mm,
came into India. Okay, so if you take,
mm,
hardly we have 25 years of experience. Okay, to the
mm,
max I'm
mm,
speaking about. But definitely, if you take in this 25 years, if you take any one Indian guy, right, who worked on the
mm,
same project in same company, you will never get one person like that.
yeah.
Okay, definitely you don't get, because they switch companies, they switch, all those things are happening. So that is the reason you don't get anyone in the global market where you can just say that, come on, my JP Morgan system is gone, my senior resource is getting retired, so now I need to take care of this business, so anyone can support this project. So you don't get anyone.
Mm,
So that's the big problem, why they are modernizing it. Okay, to that
mm,
point, this is one of the innovation points by IBM, what they come up with this ADA tool. Okay, so this tool
mm,
will able to do and complete application discovery. It will discover your application. Okay, that's the word.
mm,
Okay, and delivery intelligence is something which it will deliver an solution for you where you can discover your application. Okay, so delivery intelligence, what it does is it is able to gather the dependencies between your applications, and it is generating a database, a DB2 database model, data model. So that will have a relation between all your programs, your jobs, your interfaces, and your CICS regions, everything, so that you could able to completely discover your application on your own. Okay, that's the
mm,
main idea, and then they came up with the solution. I don't know how they made these dependencies and how, what background it is executing, but this is one of the
mm,
very good tool even for the resources who are working currently in mainframe to understand their application. Okay,
okay.
okay, with this we will just start. Okay, So we will understand the business needs for ADDA. Okay, I think I already explained this a lot, and the ADDA
mm,
architecture, how they architect this ADDA tool. Okay, and what is AD? What is application discovery with IDC? So how we are going to use this discovery, which can be plugged in as an perspective in IDC tool itself. Okay, so how
okay.
ADDA works, and we will see the application discovery perspectives, reports, and graphs. Okay.
Mm,
Okay. So this is ADDA. So application IBM application discovery and delivery intelligence is an analysis tool that helps visualize application data jobs on ZOS. Okay, it's a complete package. So that's the main idea. It's not only going to analyze your sources, COBOL. No, it going to
mm,
do it
mm,
for any kind. It can be a CS7 scheduling or your changeman or your COBOL sources, CACS maps, APL bar ones, and everything. Okay, so this is
mm,
something which will give a holistic picture of your complete application. Okay, so ADDA enables architects and developers to discover dependencies in a click. That's the main point, and implement changes with confidence and keep documentation current and accurate. Okay, so this is the main purpose of your ADDA, where you will be able to see. That's means that if a new person who is going to look into that system, he can get a better idea about the system by just doing the analyzing this system using ADDA, so that he can have a very good change where he need to make it. Okay,
mm,
and then use ADDA to enable your AD team to make informed decision about modernizing. So that also it helps not only for your current maintaining your application, but also you can use this as a complete analysis of your application, so that you can develop a new application in other application. I mean other modern languages as well. Okay, that also
mm,
it helps. Okay. So how ADDA helps? So this is the true fact, right? With million lines of codes, huge dependencies, right? One program will have as many as subprograms. Okay, from that subprograms you have as many as tables, you have as many as interfaces, and all those things. So there is huge dependencies between your things, and you have one program which creates an output file. So that will be an input file for the other job, and that creates another output file. So this is going. It's a cycle. So this is something which has huge dependency. So if you touch one point to do a change, that will impact at some other place which you never even imagined. So that's the way it has been dependent because it was all interlinked and it was has been created for years together, right? So
mm,
that's the
mm.
reason. And the lack of documentation, right? So this is one of the biggest limitations when developers are working on code changes of an existing application. You don't know what has been coded there. Okay, you have a 10,000
Mm,
lines of
mm,
code, and when you want to do some impact analysis or if you want to do some changes, you don't know what to change. So that's the main reason. If you work on a mainframe application as a developer, I think you might also known that first thing what they say is don't touch the existing code. That will
mm,
be
mm,
your
mm,
first mantra, correct?
yeah.
So that's the thing. So because even the person who is asking you to change the code, right, the senior person, he doesn't know what is
Mm,
happening on the complete code. So he first says that please don't touch the existing code, please do your code alone in that position. That's it. Okay, that's the way.
mm,
And if you want to do some impact analysis, right, it may runs many weeks and months together, because if you are going to completely change something on your system, if you want to do a bigger
mm,
impact analysis, right, it's not easy. If you have to do it on a manually, it takes weeks and months. Okay, but
mm,
now if you use a ADDA, can provide a current consumable information about assets. So how many, it gives an inventory of how many programs are there, how many copybooks are there, how many tables are there. So it is able to get the information of those as well as resources. Okay, and it will implement a plan on change with confidence, so that you can do a change with much confident rather than your manual analysis. Okay, and also
mm,
helps to keep your document accurate, so that if you once you do this analysis, you can keep this for your reference, so that you have it that this system is already, we have done the analysis.
mm,
So these are all some of the reports which will be generated by the ADDA. Okay, so if you take a program call graph, right, it gives a complete call graph between your main program, subprograms, and then your tables. So it gives a complete link. So if you have one subsystem where you have 100 programs, right? Where you have
mm,
50 subprograms and 50 main programs, then it just gives the dependencies between each and every program. Okay, that's the program call graph. Okay. Then the complexity report. So it will be able to give you a complexity report on how complex is your system. So what are all things are much logically it is very complex. So those kind of reports can be generated. Okay. And you can
mm,
also generate a program flow chart. So that will give you a flow chart of your single program. Okay. Then dead code reports. Dead code reports are something like, that is obvious that in mainframes there are a lot of programs, a lot of interfaces, a lot of tables which has never been used, but it has not been scratched. So you will get a complete dead code report. That means that this program is not called for quite some time. Then that is a dead program, right? You can scratch it. So like that, you can generate a dead code report, as well as you can generate a data flow chart. Okay, so if you have an application, then you have application dependencies between different applications, then you see how the data flow, that means how your data sets are transferred and where it is going as an endpoint. Okay.
mm,
Then you can generate a transaction cal graph. That is something with IMS and CACS, where you have a transaction which invokes which screen. Okay. And from which screen, what is the map and what is the program and everything. So you get a transaction call graph.
mm.
So this is your high level architecture of your ADDA. Okay. So what once you get your license for your ADDA, okay, the first thing what you need to do is you need to lang அந்த இதுல இருக்கு பாரு. So if you want once you get your license, right, so then you do some installations of your ADDA on IDZ and all those things that we will see later. But once you have done with
Mm,
everything, and this is your architecture, first thing is you need to provide the input to ADDA that can be from ZOS, which can be a DB2 table, um, database, ACS, IMS. DB2 database means you are not going to provide the data, you are going to provide the data model. Okay. Then you are
okay.
going to provide all your CACS transactions and the TD tables. Kicks transaction tables. Then you have
Mm, mm,
all those tables, right? So those informations. Then you going to provide your IMS informations, and you are going to provide your SMF, then TWS, control M, all those schedulers and everything. So you can provide all together as an input to your ADDA build process. So what this does is it actually runs. I don't know what script it is running or what programming it is running. I don't know, but it runs. It is runs inside your ADDA server. Okay,
mm,
that builds and it creates a repository for you. That means
okay.
it builds and it creates a database, and then it gives an it stores that in an repository. So that is your application repository. Okay, then using this you can use your IDZ as an client side, which could connect to your application repository which was built on your application to do the analysis, like you can do graphical analysis reports and where used analysis and everything. Okay.
Okay.
And then from there you can use these third party tools to download your flow diagram, download your dead code reports as an any kind of outputs like PDF, Excel, JPEG, or whatever it suits.
Mm,
Okay. And you have a dashboard on your build. So what are all things are built and where you have errors. So in any case, when you're trying to build it, right? So you
mm,
need to get some idea of that build, what has been happened on that build, right? So that you can see through the dashboard management of the ADDA. Okay. So this is the holistic architecture of the ADDA. This is how it works. Okay.
mm,
Then to install your ADDA, right, you need some software stacks to be installed, right? Once you purchase your license, IBM will be able to provide you these IBM application discovery connect for mainframe. So this connect will actually connect to your mainframe to provide you the sources like programs and everything. Okay. Then you have IBM application discovery analysis client. So that is something which you need to install and add it in the IDC as a plugin, so that you get a perspective of ADDA. Okay. Then you have some server based things which you need to do on the ADDA install. So that will install some analysis server, batch server configurations, services, build clients, and these are all something as a part of ADDA tool.
Mm.
Okay. So this will be taken care definitely by your system admin and the architects who are purchasing the license for ADDA. But just to understand what is there, this is what it is. Okay.
Okay.
And if you take ADDA complete view, yeah, this is what it is. This is the server, ADDA server, so which connects from your ZOS. Okay. You can
Mm.
do by just doing an like directly sharing your PDF and data models and everything to the server, or you can directly manually download them and then also you can add it whichever you need it, you can do it also. Okay.
Mm.
Then your build will happen, second process. Okay, the source code processed by the build and placed on the repository. So this is your repository. Then use this repo as an input workspace for your analysis client using IDC.
Okay.
Yeah, that's it. So analysis client does the source code analysis and produce reports, call graphs, and third parties tools too also can be used. So that is the main thing here. Okay. So how ADDA works? So this is your source resources, like you have COBOL programs, VMS, CSS, transaction assembler programs, everything. You pass it to the build parser. Okay, will generate a table, right? It will create a dependency table, and then that will be stored on your ADDA repository. Okay, from there you can create a
Mm.
project. That project you can use it in an IDC as an Eclipse, and you can work with it. Okay.
Okay.
So all these languages are supported by the ADD. So you can even pass a Java program for doing the analysis, right? Assembler, PL bar one, everything, Hogan, and middlewares like MQ, ADMS. So all kind of databases and middlewares and schedulers can use any schedulers, and interfaces like web-based or Eclipse-based interfaces also can be used. Okay,
Mm.
and this is your holistic architecture. Like this is your admin configuration control where you provide your sources. It can be from Git also if you are migrated to Git. Okay, and this is your production
Okay.
source files. You pass it to the ADDA server that does a build, that will do the configuration, like it does the dependency checks and everything, and creates a project on the db2 or SQL server. So that is your ADDA repository. So from there you are going to use your ADDA UI, which can be IDZ, so to do your process, I mean explore the process. Okay,
Okay.
so this is like, you know, Z DevOps, it's actually a kind of a process. You know, DevOps is mainly for the distributed systems where they already using DevOps, okay, development and operation. But if you take Z DevOps, that is something you're going to, which is a hybrid form of your mainframe SDLC process. Okay,
Mm.
so this is the just a comparison. Okay, so if you take a change management, right? So
Mm.
initially, you know, when mainframes projects were running, they have been using just an Excel or a Word document where they say this is the change request. So that is how initially it was using it. Okay, but in
Mm.
distributed systems they add Jira and other kind of tools. Okay, but
Mm.
now even in mainframe projects we are using Jira as the project collaborator and everything. Okay,
Mm.
then if you take an IDE in mainframe perspective, it was only ISPF. Okay. And
Mm.
distributed systems, they already had Eclipse, and then came the Microsoft Visual Studio Code and everything. But now in the
Mm.
hybrid way, now even for mainframes, we are using VASI Code and IDZ and even Visual Studio. Okay.
Mm.
Then for source code management, we have been using like tools like Endeavor or Changeman, right? But distributed
Mm.
system, they had Git. Okay. Now in the
Mm.
hybrid way, we'll be using Git as
Mm.
well. Okay. Then for pipeline coordinators, we don't had anything like that in mainframes. We just build the
Mm.
code, we push it, right? We promote it. That's it.
Mm.
But in distributed systems, the promotion to the server, I mean, the build will happen through one of these CI/CD orchestrations like Jenkins or Git, GitHub or those kind of things. Okay, in
mm,
hybrid way now we are using the same kind of build pipelines using DBB or Jenkins or whatever maybe. Okay,
okay.
and if you take the quality control, we normally do manual reviews on the codes and everything. We document them and
Mm,
everything. But in distributed system, they had SonarQube. SonarQube is a code validator that can validate your code based on predefined standards and other things. Okay.
mm,
Now the SonarQube is even implemented in the hybrid way. Okay, even in my
mm,
project, when I try to build a code, first it goes to the SonarQube where it validates, and even it blocks the deployment if the code standards are not proper, like the performance checks. Another thing, it does a lot of checks on the code level. Okay.
okay.
Next is build. Build you normally do by JCLs, right? Once you done with
Mm,
your edit, it automatically submits a JCL and your load module and the will be generated. Okay. And distributed
mm,
systems, they used Maven and Gradle like kind of processing tools, right? But in hybrid, you are going to use DBB as the build process.
mm,
Testing, it's all manual. Now they had JUnit test and a lot of other testing tools. And in hybrid, we have IDC ZUnit test, but that is not that much popular as of now. But we have a tool defined for that testing as well. Manual, I mean
mm,
automated testing. Then for
okay.
release management, it's all about endeavor. So you promote your code to the baseline. Okay, once during the release time. So it was done to endeavor. Here you have urban code deploy. Okay, so
Mm,
that same can be implemented for the mainframes as well. Okay,
mm,
repo and deployment manager, here everything is in endeavor, so that is the basic source code management. But here it's all about you have urban code deploy, so that can be used as a uh, repo management and deployment manager. Okay,
okay.
so now we see about application discovery. Okay, so now in we don't have a license for ADA. Okay, so we don't see this repository. Once you get your
Mm,
repository and then you installed all your client and everything, right, then you get a direct perspective like this application discovery. Okay,
okay.
using this you can connect to the project, explore the projects, and then you can connect to your repository, ADDA build repository. After that, that is a different scenario where you are going to build it. Once you build it, you get a repository. That repository can be explored using your application discovery. Okay.
Mm, mm. So the repository build will be done by developer or it is done by system admins?
No, the first initial connection between your server and other things, that will be done by the system admins. Okay,
Okay.
where
Okay.
what code you are going to pass for this analysis, right? That needs to be done by the developer.
Okay. Okay.
So, for example, you have one subsystem, okay, where you have
Mm,
100 codes of program and interface.
mm,
You
mm,
have separate libraries, right? The PDS will be there,
mm,
right?
mm, mm.
Now, if you want to analyze for your system few things, okay, then you can, as
Mm.
a one-time process, you can build this using passing all these libraries.
Okay.
Okay,
Okay.
once done, then it will be generated. Your build will be generated. Once it is generated, you can use it for any time, any kind of projects or any analysis. You can do it.
Mm, mm, mm.
Okay,
Okay.
that
Okay.
for that build, what are all folders and files you are going to pass, that is decided by you.
Mm,
Okay,
mm, mm, mm.
whenever you
Okay.
want it, you want to build it. You want to build for one subsystem today, for other system maybe day after, some other day, whenever you are doing good code changes, that time you can build it. That is on the developer level.
Mm.
Okay,
Okay. Okay.
so these are all some of the examples which has been built already. Okay, so when you
Okay.
do the explore projects, it will list all the repositories for from projects which has been built on that repository. Okay,
Mm, mm, mm,
once you click on this any one of the projects, here you have an explorer. Okay, where
mm.
you can explore the project, search in the files, screen layouts, then you have mainframe graphs, like you can generate a CS7 path, control M graphs, dataset flows, flow charts, job call graphs, job flows. These are all graphs which you can generate. Then you have mainframe reports as well, like complexity reports and other things that you will see it here. You see, if you consider about the reports, you can generate complexity report, dataset report, dead code reports, impact analysis report and inventory reports and everything can be generated for that specific
Mm.
application which you have generated. Like GenApp is one of the build which has been done. Then another is a
Okay.
hospital. Then another is a JEK bank. Then JEK bank itself, they are generated for two subsystems, V100 and V109. Then Mortgage app. So these are all different projects which has been created by the build.
Mm. Mm. Mm.
Then based on each and every project, you can do these kind of discoveries things from the IDC. Okay.
Okay.
So for example, now I am going to do a search on the missing component report. That means missing
Mm.
component means I have an code, okay, reference, but that doesn't have any link or interfaces. Okay.
Okay.
So if you want to do that, if you just click on this missing component report, then
Mm.
based on your application, it just gives that these are all programs, components, okay, which are
Mm.
used in the different programs. Okay, maybe it could have been commented, but this is something which is not used.
Mm. Mm.
Okay, like this, you can generate a report and you can download this report also.
Okay.
Okay. And then once you want to export it, you can just export it as a PDF and other things.
Mm. Mm. Okay.
Now you want to generate a program call graph. So now I
Mm.
just select the GenApp application, and if I just go to the program call graph, okay, then it
Mm.
lists the available programs which has been built on this GenApp. Okay, it lists all
Mm.
the
Mm.
programs. Okay, you can do it for one or two programs. Okay, or you can do it for the completely all programs also.
Okay.
Okay, and here you have call direction. So what is call direction is, see, you have program A, okay,
Mm.
which is actually a function. It is actually a subprogram. Okay, this program
Mm.
A can be called by program B.
Mm.
Okay, and inside this program A, you have a program C which is being called inside this program B A. Okay,
Mm.
so how you want to do it from this program? What are all subprograms are called? That is forward direction.
Mm. Mm.
If you go
Okay.
backward, then this is the program. This program is called by any program. That is the backward. If you do both, it will give both A and as well as C.
Mm.
Okay,
Mm.
so that is
Okay.
the direction of how the flow will go. Okay,
Mm.
and
Mm.
what is the limit, right? In this program, I might have one program called. Inside that program, there will be another call, another call. So how much deep you want to go?
Okay. Okay.
Okay, that also can be limited. Okay,
Mm. Mm.
once you do this, and if you just finish it, then it generates a call graph like this.
Mm. Mm.
Okay,
Okay.
you see this is the program. Okay, this program is called by this program, that is the arrow, red arrow.
Mm.
Okay,
Okay.
so this program has a map. This program has a kicks transaction SSC1. Okay, and also it has a table,
Mm.
so it gives a complete detail about this application.
Mm.
So you see the inventory also here. You have six kicks transactions. We have 36 COBOL programs. These are all the files, maps, SQL tables, everything.
Mm. Mm.
Okay, and if you
Okay.
see here, this program is called by this program as well as by this program.
Mm. Mm.
So
Okay.
like this, you can see a complete call graph of that application. This gives a holistic picture of your complete application itself. Okay,
Mm. Mm. Okay.
and even here you can just select those separately and you can do some analysis also based on which.
Mm. Okay.
Okay, if you just want to open this map, right, you will be able to do it. And if you select this, right, even it shows the command where it address that specific call,
Okay. Okay.
okay, on the program itself. Okay, and
Mm.
even if you just want to see the layout of your map, you just right click layout, screen layout, then it opens the screen layout as well from there itself.
Mm.
Okay, so
Okay.
you see how much easy to do the analysis, like, right?
Mm. Mm. Mm.
Next is how you are going to explore the project. Explore project means You just want to know how many IMS transactions, or if I want to know what is the what are all data sets, COBOL programs, control M jobs, right? So those can be done through the explore project. So you can just filter them and then you can see the name of the resources, whichever you have it.
Okay.
Okay. Then you can generate an impact analysis report. So what is impact analysis report is, if you just want to see, right? If you just click on this impact analysis report, it just opens this wizard where you say you want to target a locate variable in a program or include. Okay, so where
Mm,
actually you are going to use an include statement, okay, or you are going to browse for a table field. Table field means if you have any select and other things, right? So that also can be used. Okay,
mm,
here also you do the impact direction forward or backward, and then you can limit it. Okay,
mm,
so
mm,
once you given this and if you just give next, then it gives what you're going to analysis. You're going to analysis a program or a include. Program means inside my program I'm doing a change. Okay, I'm adding a new variable or I'm adding a new property.
mm. Yeah.
Or as a field in the working storage. Okay, which is being
Okay.
used in the error message, maybe in the output file or somewhere.
Mm, mm. Okay.
Once I click on this and then if I just finish it, right, then
Mm,
it generates a report for me. Okay, so what I'm trying to do, this is the variable, okay, which I'm going to impact analysis. Okay, now if you see
mm,
here in this program, starting program, this is the start of the program. Okay, here
mm,
I am passing this from to here. I have a move statement here to this field.
mm, mm. Okay.
Okay, and this error field is used in this program as a call program. In this program I'm passing this error message.
Mm, mm.
Okay,
Okay.
now the data flow is from this main program B01 to LGST Okay,
Mm,
now
mm,
I'm impacting the variable the program LSTQ. So here in this error message is used in the DFH COM area.
mm.
That
Okay.
means it is used in the map. Okay,
Mm,
so
mm,
like this, then this program, in this program what is happening on that specific EMS message field. So like this it keeps on digging.
mm, mm. Okay.
Okay, so you get a complete flow of where this field is moved and how if I change this where and all it will be impacting. Okay,
Mm. Okay.
now what we normally do this is I will to search in each and every program and then get okay this is used here, used here, used here, right? But it is able to generate the
Mm,
report for you. Okay,
mm. Okay.
then this is your application discovery build client. So this is where you are going to build your project. So this is actually a server based thing where you just need to select your project and then you need to provide all the sources, right? What kind of sources you have
Mm.
and then you need to pass all the thing and then you need to build the project.
Okay. So this is
Okay,
not in IDC, right? This
no,
is in
this is not,
some.
no, this is not in IDC. It is a separate server uh, tool which you need to use it.
Okay. Okay.
Okay, same like IDC, it is a different tool. It's a US based tool.
Mm-hmm.
Okay,
Mm-hmm.
so
Okay.
once you run this, right, it takes hours together because
Okay.
I didn't had any license, but when I was providing the session for one more person in he was
Mm,
working in BOA, Bank of America, and there they
mm,
purchased the license for this ADDA. Okay,
mm.
there he
Okay.
showed me like when he start this build, right, using the data, right, it takes
Mm,
hours together to prepare that project. I mean the interfaces and everything, right? So it's the build is really complex. Okay,
okay.
because it
Okay.
needs to, you know, I cannot even imagine how they did this. Okay, to my
Mm,
to my perspective, right? I don't know how the
mm,
how you can create a dependency like this, right? See, this is not this is
mm.
not easy, right? You just click on
Yeah.
the map and then if you see the layout, you are going to see the layout, right? Even
Mm,
you cannot do
mm.
this. right?
Yeah.
So and these kind of call graphs and all, definitely it's not an easy thing, because the build
Mm,
has done that. Okay,
mm,
so
mm,
in
mm,
each and every program it goes and it sees that if you have an exec transaction name and map name, then it try to
mm,
take that map and put it in a separate
mm,
fields. And then if it is a call statement, then what program it is calling, then it is making that as a call program. And if you have any SQL
mm,
statement with the table name, right, then it uses that as a table, right? So it need to create like this, right? Then only you can get the call graph like this, correct?
mm, mm.
So that's the
Yeah.
reason this build actually takes time, but once it is done, you can have it for analysis at any time.
Mm, mm, okay.
Okay, so that's the main thing about this too.
Okay.
Okay, actually these screenshots were taken by the from the ADDA trial, but now the trial is not available.
Okay.
Actually, we had this as a trial initially. Duration. This was actually a trial. I am the trial provides a pre and threshold. So if you see here you can get the trial version of all. You can try it. You see, even ZOS Connect, you can do it. You can try it out.
Mm, mm,
Okay, like this you have for Z development test environment, right? You can register a trial for this. Okay,
okay.
like this IBM application delivery foundation, VS code, open stack. This is Snow Diamonds, Mega, then just letting Zuvi also we have,
Okay.
and then addition runtime, IBM A Ops, uh, cloud database application, IT operations, Omega, and other things are there. But initially we had this for the ADDA, but now we don't
Mm,
have this. Okay, database and
okay.
application server. Mm, yes, I remember. This was my ADDA. No, fail. This was the ADDA access. This was the uh, yeah, but this doesn't work. Initially we had this trial, but now I think they stopped it somewhere. So now I'm not getting
Okay.
that trial version of ADDA. Otherwise, you can just connect this and then you can work with it.
Mm, mm, mm.
Okay, but here they have given the complete product information, like what are all things you wanted, announcing letter, what is new in ADDA, configurations and other things, new endpoint, enhanced control M usage, Copon 6.4, everything. Java, IBM edited documentation, HTML versions, product. Okay, see here they had one thing.
Okay.
This is not actually opening. Image profile. This goes here. And if I just get started, and if I just give my name and ID. Center. No, it's just saying it, but it is not actually generating the thing. So this is the reason we are not able to trial it again. Because
Mm, mm,
previously it was having this, so that we will be able to directly work like this. It's a VM, so where you can just log into that
mm,
VM,
mm,
and already they would have generated all these projects like here,
mm,
like what you
mm.
see here. So from there only these screenshots were taken actually.
Okay.
So, but now they stopped this trial. Maybe I'll check with Mama if she has any other connections to this. Okay, but this is the
Okay.
complete picture of ADDA. Okay, this is how it works. So
Mm, mm,
if there's something which is there in your project, or if they are going to work on it, then really you have a very good exposure, and this is really a good tool to be work with. But this is licensed.
mm, mm. Okay. Okay.
Yeah. So we will connect on Thursday. Okay, we will
Okay.
start with Git. Okay, fine.
Okay.
Yeah,
Okay. Fine, Arun.
yeah,
Yeah.
fine.
Thank you.
Yeah, thank you.